In this video we shall review normalization step-by-step sample. Imagine we have to store the following data: employee full name, employee position, employee department, department phones, if a corporate car should be available for an employee, names and birth dates of all employees' children. We shall start from the zero normal form. We may have such a relation. It would consist of one column only, and each row would contain all the data about each employee. This is the worst situation ever. It is absolutely impossible to work with such a relation, so we shall never do such things, and of course we shall normalize it starting with the first normal form. Here you see two variants with natural primary key and surrogate primary key. And let's talk about atomization of attributes. Are these attributes atomized? This attribute brings questions. This does not, it's okay, it's okay. This attribute brings questions. This is okay, and this is okay. So what about employee names? Of course, in real life situation, we shall put this first name, this middle name, and their family name in separate columns. But for educational purpose, let's assume that the customer says that he will never need this information in separate form, so we may consider this attribute atomized. But the department has several phones, and we cannot store all that information in one single field. Otherwise, we have a compound value, and that's the violation of the first normal form. So we have to deal with this field. Let's do it. This is how it looks like with natural and surrogate PK. This situation looks somehow easier, so let's see here. We have all phones in a separate relation, in a separate table. So now we do not have a compound attribute, and if we look attentively to these relations here and here, we may see that initial field is still here and is still here. That's not a mistake, that's just a sample of the idea that we may use it as caching attribute. But of course, in further normalization, we shall eliminate it from here, and we shall see it in a couple of seconds. But for now, we have no non-atomized attributes, so the first normal form is achieved. With second normal form, we have to eliminate partial dependencies. What partial dependencies do we have here, or did we have here, as long as this is the final situation? We see that this information about if corporate car should be available to an employee or not is dependent on the position only. The information about department phone is dependent on the department only, but that information about position and the department is stored here in compound primary key. So that information was partially dependent on the primary key, on this part or this part. Once we've moved that information into other relations, we have no partial dependencies here, and the second normal form is achieved. To achieve the third normal form, we have to eliminate transitional dependencies. What transitional dependencies did we have here? This is information about child date of birth, and it is dependent on child name. What child is it? And that information about child name was dependent on the primary key. So we have our employee, we have then child, and then we have that child date of birth. And that's the transitional dependency that was here and now it's not here, as long as this is the final view. How did we eliminate that dependency? We've moved information about children into a separate relation. And now we may analyze the situation and see if we for real have the third normal form. Let's start with the first normal form. Of course, we've agreed that all these relations has only atomized attributes, so the first normal form is achieved, it's okay. What about second normal form? Can we have some partial dependencies here? We cannot have such dependencies neither here nor here, as long as we have the primary key consisting of one field only. Let's analyze here. Okay, here also one field in the primary key and also one field in the primary key. And here, yes, also one field in primary key. So no partial dependencies and the second form is achieved. And what about the third normal form? In order to have that transitional dependency, we have to have the primary key, then some field, and then that dependent field. And we have to have such sequence. Let's start from the top. Okay, we have children, we have the child ID. Information about what parent this child have depends on the child ID. The name of the child depends on the child ID, on what a child is this, and the date of birth also depends on that child ID. Everything's okay here. Let's review phones. We have phone ID, we have information about what department that phone belongs to, and it depends on the phone ID. And the phone number depends on the phone ID. Everything's okay here. What about employee? We have an ID, and the position depends on what employee is it, and his department depends on what employee is it, and his full name depends on the same information. So no transitional dependencies here. What about department? We have two fields only, so no transitional dependencies by definition. What about position? We have ID, and we have that position name that depends on ID, and we have that information about car that depends on the position ID. So everything's okay here, and we see that we have the third normal form for the whole database. You may easily repeat that analysis for natural primary key with this picture. And yes, that's all, because further normalization for this particular database is both unnecessary and even impossible. Of course, with the evolution of this database, when we add another relations, the question of normalization may arise. But here, even if we make something magically and create some more normalization here, it would be absolutely unnecessary, and we'll have to use denormalization to return back to the initial situation. That's why we may say that the third normal form is the final for this particular database, and one can say that for most simple databases, the third normal form is the final, the ultimate one. And finally, that's all about normalization.